Okay, this video is a continuation of examples of trigonometric functions, equations that we started. We went up to D, so in E we have got sine of pi on 3 minus 2 theta is equal to negative root 2 on 2. So as usual, the first question we're going to ask is in which quadrant is sine negative, and we will remember that sine is negative in quadrant 3 and quadrant 4, so we expect two angles in those two quadrants when we take inverse sine. So if we do that, so let's take inverse sine. It's going to give us pi over 3 minus 2 theta. So inverse sine negative root 2 over 2. So punching that in the calculator, inverse sine negative root 2 negative root 2, negative is not there, and then divided by 2, so that gives us negative 45, so that must be that one there. By the way, it's completely acceptable to write negative 45. If you like, you can write 315. That is okay. Those two are coterminal. Then it means this is 45 as well. So 180 plus 45, that is going to be 225. And then we do 360k, but remember that this is not theta, this is pi over 3 minus 2 theta, so we still have to solve for theta. I think it's gonna be helpful if you write that pi over 3 in degrees. So that is what I have done. And then what we're going to do is we need to make theta the subject of the formula here. So we can take this to this side and take those to that side. So we're going to have 2 theta is equal to so that is going to be 60 plus 45, so it's going to be 105 degrees, 360k. Since this k is like plus and minus, you can just keep it as positive. Then the other one is going to be 60 minus 225, so 60 minus 225, so it's going to be negative 165 plus 360k. Then finally theta is going to be 105 over 2 plus 180k. This one is going to be negative 165 over 2 plus 180k. And then you can convert this to radians. I'm just going to go to number 2. So in part 2, if you start with this one, 105 over 2 divided by 2, 52.5. So 52.5 is in the interval of interest, but if we add 180, then we're going to go outside. But if we subtract 180, which we'll do just now, minus 180, we're still going to be in that inside that specified interval, negative 127.5. Then for the other one, so 165 divided by 2, let's make it negative, so it's negative 82.5. If we add 180 to this, we're going to get an angle which is still inside the interval, so that's going to be 97.5. Okay, so this time we find 4 angles in the 360 interval. The reason for that is these 2 here, because that 2 determines the frequency of your sine curve. If it's 1 here, then you have got 1 complete oscillation between 0 and 360. If it's 2, then you have got 2, so that's why we end up with 4 of those answers. So let's go to F. In F, we have cosine theta minus sine 2 theta is equal to 0. The 2 methods of solving this one, so I'll do both of them. So in the first case, we're just going to write this using double angle formulas. So got cos theta minus 2 sine theta cos theta equal to 0. Then cosine theta is common, so we factorize it. Then this is implying that either cosine theta is 0 or sine theta is equal to 1/2. Sine theta is 1/2. We already solved in example A, so we already have the solutions for this one. Is cosine theta equals to 0 that we need to solve. So the question we need to ask ourselves is, where is cosine 0? And you might recall that this is going to be when theta is 90, but if you don't remember that, we can work it out as follows systematically. We know in the first quadrant cosine is positive, and the second quadrant cosine is negative. It's negative here and it's positive here. Now so cosine from here to there goes from positive to negative, so goes from positive to negative. In between there, it must go through 0, so that means cosine must be 0 there at 90. Same thing here, negative to positive, so in between there, so that means cosine must be 0 at 90 or 270. But of course we could just punch this in the calculator. So it's just that if you have understanding of what's going on, then you are you are better equipped. Okay, so inverse cosine is 90, so that's giving us right, so that's giving us the 90, but since these are in a straight line, we can simply do 90 plus multiples of 180, and so in radians is going to be pi on 2 plus pi k. So our solution for part 2, we are going to have 90, negative 90, and then for the sine theta is half, you're going to remember we've got 30 and 150. So in radians is going to be plus or minus pi on 2, pi on 6 here, and then pi on 6 there. So again, we've got 4 solutions because this is actually a quadratic in sine and cosine. All right, so that's FG. In G we have cosine 2 theta plus cosine theta is equal to 1. So here cosine 2 theta, we need to use double angle formulas, but since the other term is already a cosine, then we need the double angle formula that expresses cosine 2 theta in terms of cosine. So it's going to be cosine squared theta minus 1. So I'm going to write this as 2 cosine squared theta minus 1 plus cosine theta is equal to 1. So this is going to be 2 cosine squared theta plus cosine theta minus 2. So this is a quadratic in cosine, so we can try and factorize it. If we put one of these is going to be 2. So if we put, okay, I think this question has got a typo, otherwise it's working out to something more complicated than we want. So what it should have been minus 1 here. So if that's minus 1 there, then it's just going to be 2 cosine squared theta plus cosine theta. Then we can factor out cosine theta here. We're going to have 2 cosine theta plus 1 is equal to 0. Then we're going to get 2 equations that we have already solved. It's going to cosine theta is negative half. Cosine theta is 0. We solved in the previous example. Cosine theta is negative half. We solved in part B. So you can refer to those ones. Okay, then, so the Ross GH has, so H has 2 sine squared theta minus cosine theta minus 1 is equal to 0. So here we have got a sine here and a cosine here. So what we're going to do is we're going to write the sine squared in terms of cosine using the fact that sine squared theta plus cosine squared theta is 1. So sine squared theta is 1 minus cosine squared theta. So here we're going to plug in 1 minus cosine squared theta, and then minus cosine theta minus 1 equal to 0. So this is going to be 2 minus 2 cosine squared theta minus cosine theta minus 1 equal to 0. If you take everything to the other side, we're going to have 2 cosine squared theta plus cosine theta minus 1. Then this we can factorize. 1 here is going to be plus, and this is going to be minus, equal to 0. So the first one gives us cosine theta is 1/2. Second gives us cosine theta is -1. So we need to do one at a time. We'll just do the general solutions and then you can do the particular solutions. Cosine theta is 1/2. So we have to ask the question, where is cosine positive? And that's going to be first and fourth quadrant. Then if we do inverse cosine 1/2, we are going to get 60 in the first quadrant, and well, can either write -60 or 300 in the fourth quadrant. And then you can convert them to radians, etc., and find the ones in the interval. Now minus pi to pi, where is cosine going to be -1? So remember, I said it's positive here, it's negative here, it's positive here, it's negative here. So cosine is going to be -1 in the, so if you look at this diagram like this, so cosine is positive here and the negative here, so it means it's decreasing. Okay, and then it keeps decreasing. This is the minimum that it's going to be, so that's when it's going to be -1. Okay, then from here to here it's now decreasing, so this side is 1 and that side is -1. So this one is just going to give us 180 and then plus 360k. Then when we're looking for the particular solution, we're going to have plus or minus 60. We are going to have 180, and then we can write this in radians, and so that's going to be your 3 solutions for this one. Okay, let's give you a few examples, maybe 3. All right, so if you want to have a go at these 3, in part I, we have cosine of 2 theta plus 120 degrees equals to √312. In J, we've got sine theta plus √3 cos theta is 0. In K, got 2 cos squared theta plus 3 sine theta equal to 0. So please just have a go at these. and then you can compare with our answers. Alright, so I imagine you've been having a go at these three exercises here. I'm going to start by going back to F. In F, I say there are two methods of working out this problem here. And then I forgot to go through the second method. Using method 1, we found that the solutions are 30, 90, 150 and 270 with their coterminal relatives. So this time in method 2, we're going to use the fact that we mentioned that cosine theta is sine of 90 minus theta and vice versa. So sine theta is cosine of 90 minus theta. So here, if we take sine 2 theta to the other side, we've got cosine theta is sine 2 theta. And then this we can write in terms of sine as sine 90 minus theta. Now, since we've got sine and sine here, then the angles must be equal. Well, yeah, and they are coterminal equivalents, of course. So we're going to have 90 minus theta is 2 theta, and then we're going to add multiples of 360 here. If we make theta the subject, so take theta to the side, get theta 3 theta, and then so we get theta is 30 minus 120k. Now if we generate the values of theta here, so of course obviously when k is 0, it's going to give us 30. When k is 1, there's going to be 30 minus 120. So 30 minus 120 is negative 90. And then if we subtract 120 again, we get negative 210. And then on the other side, if we say 30 plus 120, we are going to get 150. And then 150 plus 120, we're going to get 270. And I'm sure you can see by now that all these have been covered. So we have got 30 here, which is this one. We have got okay, we don't have 90 yet, but we have 150 here. We have got 270 here. I've got negative 210 there. I think if we just take we've got negative 210 and then minus 120, we're going to get negative 330, and then minus 120, we're going to get negative 450. Now negative 450 is an angle between 0 and 360 is going to be equal to negative 90, which we already have. Okay, so yeah, there you are. No, we still haven't found 90. All right, yeah, well, actually we already have 90, because negative 90 is 270 actually. All right, looks like this method is not picking up the 90. I'll investigate and report back. All right, so for I, we've got cosine 2 theta plus 120 equals to root 3 on 2. So we ask ourselves, where is cosine positive? Going to be the first quadrant and the fourth quadrant. And then we take inverse cosine of root 3 on 2. It's going to give us 30 or minus 30. Then we subtract 120 on both sides. So we're going to have negative 90, negative 150 here. And then we divide by 2. And so that's going to be our general solution there. And then from there, by just varying the values of k, we're going to come up with 4 values of the particular solution. In J, if we take cosine to the right hand side and then divide by cosine on both sides, so it's going to give us tangent is negative root 3. If we take the inverse tangent, it's going to give us 120. And so the particular solutions will be those ones. Here, if we, in K, if we write cosine squared in terms of sine here, and simplify, we get 2 sine squared theta minus 3 sine theta minus 2. So that gives us either sine theta is negative half or sine theta is 2. Of course, this one is impossible because sine and cos are always between negative 1 and 1. Solving this one gives us negative 30 and 210, because sine is negative in the fourth quadrant and in the third quadrant, and then we write that in radians, and then the particular values will look like that.